Running the persistence examples. This chapter explains how to use the Java persistence API. The material here focuses on the source code and settings of 3 examples. The first example, order, is an application that uses a stateful session bean to manage entities related to an ordering system. The second example, roster, is an application that manages a community sports system. The third example, address book, is a web application that stores contact data. This chapter assumes that you are familiar with the concepts detailed in Chapter 32, Introduction to the Java Persistence API. The following topics are addressed here: the order application, the roster application, the address book application, the order application. The order application is a simple inventory and ordering application for maintaining a catalog of parts and placing an itemized order of those parts. The application has entities that represent parts, vendors, orders, and line items. These entities are accessed using a stateful session bean that holds the business logic of the application. A simple singleton session bean creates the initial entities on application deployment. A faceless web application manipulates the data and displays data from the catalog. The information contained in an order can be divided into elements. What is the order number? What parts are included in the order? What parts make up that part? Who makes the part? What are the specifications for the part? Are there any schematics for the part? The order application is a simplified version of an ordering system that has all these elements. The order application consists of a single WAR module that includes the enterprise bean classes, the entities, the support classes, and the facelets XHTML and class files. Entity relationships in the order application. The order application demonstrates several types of entity relationships: self-referential, one-to-one, one-to-many, many-to-one, and unidirectional relationships. Self-referential relationships. A self-referential relationship occurs between relationship fields in the same entity. Part has a field, BOM part, which has a one-to-many relationship with the field parts, which is also in part. That is, a part can be made up of many parts, and each of those parts has exactly one bill of material part. The primary key for part is a compound primary key, a combination of the part number and revision fields. This key is mapped to the part number and revision columns in the EJB order part table, many-to-one. Join columns. Join column name equal BOM part number, reference column name equal part number. Join column name equal BOM revision, reference column name equal revision public part get BOM part return BOM part. One-to-many map by equal BOM part public collection. Part. Get parts return parts. One-to-one relationships. Part has a field, vendor part, that has a one-to-one relationship with vendor parts part field. That is, each part has exactly one vendor part, and vice versa. Here is the relationship mapping in part. One-to-one map by equal part public vendor part get vendor part return vendor part. Here is the relationship mapping in vendor part. One-to-one. Join columns. Join column name equal part number, reference column name equal part number. Join column name equal part revision, reference column name equal revision. Public part get part return part. Note that, because part uses a compound primary key, the join columns annotation is used to map the columns in the persistence order vendor part table to the columns in persistence order part. The persistence order vendor part table's part revision column refers to persistence order parts revision column, one-to-many relationship mapped to overlapping primary and foreign keys. Order has a field, line items, that has a one-to-many relationship with line items field order. That is, each order has one or more line item. Line item uses a compound primary key that is made up of the order it and item it fields. This compound primary key maps to the order it and item columns in the persistence order lane eating table. Order it is a foreign key to the order it column in the persistence order table. This means that the order it column is mapped twice. Once as a primary key field, order it, and again as a relationship field, order. Here's the relationship mapping in order. One-to-many cascade equal ALL, map by equal order public collection. Line item. Get line items, return line items. Here is the relationship mapping in line item. Many to one public order, get order, return order. Unidirectional relationships. Line item has a field, vendor part, that has a unidirectional many to one relationship with vendor part. That is, there is no field in the target entity in this relationship. Many to one public vendor part, get vendor part, return vendor part. Primary keys in the order application. The order application uses several types of primary keys. Single-valued primary keys, compound primary keys, and generated primary keys. Generated primary keys. Vendor part uses a generated primary key value. That is, the application does not assign primary key values for the entities but instead relies on the persistence provider to generate the primary key values. The generated value annotation is used to specify that an entity will use a generated primary key. In vendor part, the following code specifies the settings for generating primary key values. Table generator name equal vendor part gen. Table equal persistence order sequence generator. PK column name equal gen key. Value column name equal gen value. PK column value equal vendor part id. Allocation size equal 10. Id. Generated value strategy equal generation type. Table generator equal vendor part gen public long id vendor part number return vendor part number. The table generator annotation is used in conjunction with generated values strategy equal table element. That is, the strategy used to generate the primary keys is to use a table in the database. The table generator annotation is used to configure the settings for the generator table. The name element sets the name of the generator, which is vendor part gen in vendor part. The EJB order sequence generator table, whose two columns are gen key and gen value, will store the generated primary key values. This table could be used to generate other entities' primary keys, so the PK column value element is set to vendor part id to distinguish this entity's generated primary keys from other entities' generated primary keys. The allocation size element specifies the amount to increment when allocating primary key values. In this case, each vendor part's primary key will increment by 10. The primary key field vendor part number is of type long, as the generated primary keys field must be an integral type, compound primary keys. A compound primary key is made up of multiple fields and follows the requirements described in primary keys and entities. To use the compound primary key, you must create a wrapper class. In order, two entities use compound primary keys, part and line item. Part uses the part key wrapper class. Part's primary key is a combination of the part number and a revision number. Part key encapsulates this primary key. Line item uses the line item key class. Line item's primary key is a combination of the order number and the item number. Line item key encapsulates this primary key. This is the line item key compound primary key wrapper class. Package order. Entity, public final class line item key implements Java. I/O. Serializable private integer order id, private int item id, public int hash code return this. Get order id null. 0. This. Get order id. Hash code int this. Get item id. Public boolean equals object other ob if this other ob return true. If other ob instantia of line item key return false. Line item key other equal line item key other ob, return this. Get order id null. Other. Order id null. This. Get order id. Equals other. Order id this. Get item id other. Item id. Public string to string return plus order id plus dash plus item id. The id class annotation is used to specify the primary key class in the entity class. In line item, id class is used as follows. Id class order. Entity. Line item key. Class. Entity. Public class line item. The two fields in line item are tagged with a id annotation to mark those fields as part of the compound primary key. Id public id get item id return item id. Column name equal order id, nullable equal false, insertable equal false, updatable equal false, public integer get order id return order id. For order id, you also use the column annotation to specify the column name in the table and that this column should not be inserted or updated, as it is an overlapping foreign key pointing at the persistence order table's order id column C1 to many relationship map to overlapping primary and foreign keys. That is, order id will be set by the order entity. In line items constructor, the line item number line item id is set using the order get next id method. Public line item order in quantity vendor part this order equal order this item id equal order get next id this order id equal order get order id this quantity equal quantity this vendor part equal vendor part order get next id counts the number of current line items, adds 1, and returns that number. Public id get next id return this line items size +1. Part doesn't require the column annotation on the two fields that comprise part's compound primary key, because part's compound primary key is not an overlapping primary key. Foreign key. Id class order. Entity. Part key. Class. Entity. Public class part. Id public string get part number return part number. Id public id get revision return revision. Entity map to more than one database table. Parts fields map to more than one database table. Persistence order part and persistence order part detail. The persistence order part detail table holds the specification and schematics for the part. The secondary table annotation is used to specify the secondary table. Entity. Table name equal persistence order part. Secondary table name equal persistence order part detail. PK join columns equal. Primary key join column name equal part number. Reference column name equal part number. Primary key join column name equal revision. Reference column name equal revision. Public class part. Persistence order part detail and persistence order part share the same primary key values. The PK join columns element of secondary table is used to specify that persistence order part details primary key columns are foreign keys to persistence order part. The primary key join column annotation sets the primary key column names and specifies which column in the primary table the column refers to. In this case, the primary key column names for both persistence order part detail and persistence order part are the same, part number and revision, respectively. Cascade operations in the order application. Entities that have relationships to other entities often have dependencies on the existence of the other entity in the relationship. For example, a line item is part of an order. If the order is deleted, then the line item also should be deleted. This is called the cascade delete relationship. In order, there are two cascade delete dependencies in the entity relationships. If the order to which a line item is related is deleted, the line item also should be deleted. If the vendor to which a vendor part is related is deleted, the vendor part also should be deleted. You specify the cascade operations for entity relationships by setting the cascade element in the inverse non-owning side of the relationship. The cascade element is set to ALL in the case of order. Line items. This means that all persistence operations deletes, updates, and so on are cascaded from orders to line items. Here is the relationship mapping in order. One-to-many cascade equal ALL, map by equal order public collection. Line item. Get line items return line items. Here is the relationship mapping in line item. Many to one public order get order return order. Blob and CLOB database types in the order application. The part tail table in the database has a column, drawing, of type blob. Blob stands for binary large objects, which are used for storing binary data, such as an image. The drawing column is mapped to the field part. Drawing of type Java. IO. Serializable. The lob annotation is used to denote that the field is large object. Column table equal persistence order part detail. Lob public serializable get drawing return drawing. Persistence order part detail also has a column specification of type clob. Clob stands for character large objects, which are used to store string data too large to be stored in a varchar column. Specification is mapped to the field part. Specification of type Java. Lang. String. The lob annotation is also used here to denote that the field is a large object. Column table equal persistence order part detail. Lob public string get specification return specification. Both of these fields use the column annotation and set the table element to the secondary table. Temporal types in the order application. The order. Last update persistent property, which is of type Java. Util. Date is mapped to the persistence order. Last update database field, which is of the SQL type timestamp. To ensure the proper mapping between these types, you must use the temporal annotation with the proper temporal type specified in temporal's element. Temporal's elements are of type JavaX. Persistence. Temporal type. The possible values are date, which maps to Java. SQL. Datetime, which maps to Java. SQL. Timestamp, which maps to Java. SQL. Timestamp. Here is the relevant section of order. Temporal timestamp public date get last update return last update. Managing the order applications entities. The request bean stateful session bean contains the business logic and manages the entities of order. Request bean uses the persistence context annotation to retrieve an entity manager instance, which is used to manage orders entities and request bean's business methods. Persistence context private entity manager M. This entity manager instance is a container managed entity manager, so the container takes care of all the transactions involved in the managing orders entities. Creating entities. The request bean create part business method creates a new part entity. The entity manager persist method is used to persist the newly created entity to the database. Part equal new part number, revision, description, revision date, specification, drawing. M. Persist part. The config bean singleton session bean is used to initialize the data in order. Config bean is annotated with startup, which indicates that the EJB container should create config bean when order is deployed. The create data method is annotated with post construct and creates the initial entities used by order by calling request bean's business methods. Finding entities. The request bean get order price business method returns the price of a given order based on the order ID. The entity manager find method is used to retrieve the entity from the database. Order equal M. Find order. Class order ID. The first argument of entity manager. Find is the entity class, and the second is the primary key. Setting entity relationships. The request bean create vendor part business method creates a vendor part associated with a particular vendor. The entity manager persist method is used to persist the newly created vendor part entity to the database and the vendor part. Set vendor and vendor. Set vendor part methods are used to associate the vendor part with the vendor. Part key PKY equal new part key. PKY. Part number equal part number. PKY. Revision equal revision. Part equal M. Find part. Class PKY. Vendor part equal new vendor part description. Price part. M. Persist vendor part. Vendor equal M. Find vendor. Class vendor ID. Vendor. Add vendor part. Vendor part. Set vendor. Using queries. The request bean. Adjust order discount business method updates the discount apply to all orders. This method uses the find all orders named query to find in order. Named query name equal find all orders. Query equals select O from order O. The entity manager. Create named query method is used to run the query. Because the query returns a list of all the orders, the query get result list method is used. List orders equal M. Create named query find all orders. Get result list. The request bean. Get total price per vendor business method returns the total price of all the parts for a particular vendor. This method uses a name parameter, id, defined in the named query find total vendor part price per vendor defined in vendor part. Named query name equal find total vendor part price per vendor. Query equal select sum VP. Price plus from vendor part VP plus, where VP. Vendor. Vendor id equal. Id. When running the query set parameter method is used to set the name parameter id to the value of vendor id, the parameter to request bean. Get total price per vendor. Return double M. Create named query find total vendor part price per vendor. Set parameter id, vendor id. Get single result. The query get single result method is used for this query because the query returns a single value. Removing entities. The request bean. Remove order business method deletes a given order from the database. This method uses the entity manager. Remove method to delete the entity from the database. Order equal M. Find order. Class order id. M. Remove order. Building, packaging, deploying, and running the order application. This section explains how to build, package, deploy, and run the order application. To do this, you will create the database tables in the Java DB server, then build, deploy, and run the example. To build, package, deploy, and run order using NetBeans IDE. From the File menu, choose Open Project. In the Open Project dialog, navigate to Tut Install. Examples. Persistence. Select the order folder. Select the Open as Main Project checkbox. Click Open Project. In the Projects tab, right-click the order project and select Run. NetBeans IDE opens a web browser to HTTP. Localhost 8080. Order. To build, package, deploy, and run order using ant. In the terminal window, go to Tut Install. Examples. Persistence. Order. Type the following command, and this runs the default task, which compiles the source files and packages the application into a WAR file located at Tut Install. Examples. Persistence. Order. Dist. Order. War. To deploy the WAR, make sure that the Glassfish server is started, then type the following command, and deploy open a web browser to HTTP. Localhost 8080. Order. To create and update the order data. The all task. As a convenience, the all task will build, package, deploy, and run the application. To do this, type the following command, and all the roster application. The roster application maintains the team rosters for players in recreational sports leagues. The application has 4 components: Java Persistence API Entities Player, Team, and League, a stateful session bean request bean, an application client roster client, and 3 helper classes Player Details, Team Details, and League Details. Functionally, roster is similar to the order application, with 3 new features that order does not have. Many-to-many relationships, entity inheritance, and automatic table creation at deployment time. Relationships in the roster application. A recreational sports system has the following relationships. A player can be on many teams. A team can have many players. A team is in exactly one league. A league has many teams. In roster, the system is reflected by the following relationships between the player, team, and league entities. There is a many-to-many relationship between player and team. There is a many-to-one relationship between team and league. The many-to-many relationship in roster. The many-to-many relationship between player and team is specified by using the many-to-many annotation. In team, Java, the many-to-many annotation decorates the getPlayers method. Many-to-many. Join table name equal EJB roster team player, join columns equal. Join column name equal teamid, reference column name equal Idaho, inverse join columns equal. Join column name equal player id, reference column name equal Idaho. Public collection. Player. Get players return players. The join table annotation is used to specify a database table that will associate player IDs with team IDs. The entity that specifies the join table is the owner of the relationship, so the team entity is the owner of the relationship with the player entity. Because roster uses automatic table creation at deployment time, the container will create a join table named EJB roster team player. Player is the inverse, or non-owning, side of the relationship with team. As one-to-one and many-to-one relationships, the non-owning side is marked by the map by element in the relationship annotation. Because the relationship between player and team is bidirectional, the choice of which entity is the owner of the relationship is arbitrary. In player Java, the many-to-many annotation decorates the getTeams method. Many-to-many map by equal players public collection. Team. getTeams return teams. Entity inheritance in the roster application. The roster application shows how to use entity inheritance, as described in entity inheritance. The league entity in roster is an abstract entity with two concrete subclasses, Summer League and Winter League. Because league is an abstract class, it cannot be instantiated. Entity. Table name equal EJB roster league public abstract class league implements Java. I/O. Serializable. Instead, when creating a league, clients use Summer League or Winter League. Summer League and Winter League inherit the persistent properties defined in League and add only a constructor that verifies that the sport parameter matches the type of sport allowed in add seasonal league. For example, here is the Summer League entity. Entity public class Summer League extends League implements Java. I/O. Serializable. Creates a new instance of Summer League. Public Summer League. Public Summer League string id, string name, string sport throws incorrect sport exception this. Id equal id, this. Name equal name, if sport. Equals ignore case swimming sport. Equals ignore case soccer sport. Equals ignore case basketball sport. Equals ignore case baseball this. Sport equals sport. Else throw new incorrect sport exception sport is not a summer sport. The roster application uses the default mapping strategy of inheritance type. Single table, so the inheritance annotation is not required. If you want to use a different mapping strategy, decorate league with inheritance and specify the mapping strategy in the strategy element. Entity. Inheritance strategy equal joined. Table name equal EJB roster league public abstract class league implements Java. I/O. Serializable. The roster application uses the default discriminator column name, so the discriminator column annotation is not required. Because you are using automatic table generation in roster, the persistence provider will create a discriminator column called DTYPE in the EJB roster league table, which will store the name of the inherited entity used to create the league. If you want to use a different name for the discriminator column, decorate league with discriminator column and set the name element, entity. Discriminator column name equal discriminator. Table name equal EJB roster league public abstract class league implements Java. I/O. Serializable. Criteria queries in the roster application. The roster application uses criteria API queries, as opposed to the JPQL queries used in order. Criteria queries are Java programming language, type passive queries defined in the business tier of roster, in the request bean stateless session bean, metamodel classes in the roster application. Metamodel classes model an entity's attributes and are used by criteria queries to navigate to an entity's attributes. Each entity class in roster has a corresponding metamodel class, generated at compile time, with the same package name as the entity and appended with an underscore character. For example, the roster entity person entity has a corresponding metamodel class, roster entity person. Each persistent field or property in the entity class has a corresponding attribute in the entity's metamodel class. For the person entity, the corresponding metamodel class is static metamodel person. Class person public static volatile singular attribute. Player string. Id public static volatile singular attribute. Player string. Name public static volatile singular attribute. Player string. Position public static volatile singular attribute. Player double. Salary public static volatile collection attribute. Player team. Teams. Obtaining a criteria builder instance in request bean. The criteria builder interface defines methods to create criteria query objects and create expressions for modifying those query objects. Request bean creates an instance of criteria builder by using a post construct method init. Persistence context private entity manager m. Private criteria builder cb. Post construct private void init cb equal m. Get criteria builder. The entity manager instance is injected at runtime, and then that entity manager object is used to create the criteria builder instance by calling get criteria builder. The criteria builder instance is created in a post construct method to ensure that the entity manager instance has been injected by the enterprise bean container, creating criteria queries in request bean's business methods. Many of the business methods in request bean define criteria queries. One business method, getPlayersByPosition, returns a list of players who play a particular position on a team, public list. Player details. GetPlayersByPosition string position logger. Info getPlayersByPosition. List. Player. Players equal null. Try criteria query. Player. CQ equals CB. Create query player. Class. If CQ equal no root. Player. Player equals CQ. From player. Class. Set the where clause CQ. Where CB equal player. Get player. Position. CQ. Select player. Type query. Player. Q equal M. Create query CQ. Players equal Q. Get result list. Return copy players to details players. Catch exception X throw new edge exception X. A query object is created by calling the criteria builder object's createQuery method with the type set to player because the query will return a list of players. The query root, the base entity from which the query will navigate to find the entity's attributes and related entities, is created by calling the from method of the query object. This sets the from clause of the query. The where clause, set by calling the where method on the query object, restricts the results of the query according to the conditions of an expression. The criteria builder equal method compares the two expressions. In getPlayersByPosition, the position attribute of the player metamodel class, accessed by calling the get method of the query root, is compared to the position parameter passed to getPlayersByPosition. The select clause of the query is set by calling the select method of the query object. The query will return player entities, so the query root object is passed as a parameter to select. The query object is prepared for execution by calling entity manager. Create query, which returns a type query. T, object with the type of the query, in this case player. This type query object is used to execute the query, which occurs when the getResultList method is called, and a list. Player. Collection is returned. Automatic table generation in the roster application. At deployment time, the Glassfish server will automatically drop and create the database tables used by roster. This is done by setting the Eclipse link DDL generation property to drop and create tables in persistence. XML version equal 1. 0 encoding equal UTF-8. Persistence version equal to 0 XMLNS equal HTTP. Java. Sun. Com. XML. NS. Persistence XMLNS. G equal HTTP. W3. Org. 2001. XMLSCHEMA instance G. Schema location equal HTTP. Java. Sun. Com. XML. NS. Persistence HTTP. Java. Sun. Com. XML. NS. Persistence. Persistence 20. XSD. Persistence unit name equal M. Transaction type equal JTA. JTA data source. JDBC. Default. JTA data source. Properties. Property name equal Eclipse link. DDL generation value equal drop and create tables. Properties. Persistence unit. Persistence. This feature is specific to the Java Persistence API provider used by the Glassfish server and is non-portable across Java EA servers. Automatic table creation is useful for development purposes, however, any Eclipse link. DDL generation property may be removed from persistence. XML when preparing the application for production use or when deploying to other Java EA servers. Building, packaging, deploying, and running the roster application. This section explains how to build, package, deploy, and run the roster application. You can do this using either NetBeans IDE or Ant. To build, package, deploy, and run roster using NetBeans IDE. From the File menu, choose Open Project. In the Open Project dialog, navigate to Tut Install. Examples. Persistence. Select the roster folder. Select the Open as Main Project and Open Required Projects checkboxes. Click Open Project. In the Projects tab, right-click the roster project and select Run. You will see the following partial output from the application client in the Output tab. List all players in Team T2, P6 Ian Carlisle goalkeeper 555. 0 P7 Rebecca Struthers midfielder 777. 0 P8 and Anderson forward 65. 0 P9 Jen Wesley defender 100. 0 P10 Terry Smithson midfielder 100. 0 List all teams in League L1 T1 Honeybees Visalia T2 Gophers Manteca T5 Crows Orland List all defenders. P2 Alice Smith defender 505. 0 P5 Barney Bold defender 100. 0 P9 Jen Wesley defender 100. 0 P22 Janice Walker defender 857. 0 P25 Frank Fletcher defender 399. 0. To build, package, deploy, and run roster using Ant. In a terminal window, go to Tut Install. Examples. Persistence. Roster. Type the following command. Ant. This runs the default task, which compiles the source files and packages the application into an EAR file located at Tut Install. Examples. Persistence. Roster. Dist. Roster. EAR. To deploy the EAR, make sure that the Glassfish server is started. Then type the following command, and deploy. The build system will check whether the Java DB database server is running and start it. If it is not running, then deploy roster. EAR. The Glassfish server will then drop and create the database tables during deployment, as specified in persistence. XML. After roster. EAR is deployed, a client jar, roster client. Jar is retrieved. This contains the application client. To run the application client, type the following command, and run. You will see the output, which begins. Echo running application client container, exec list all players in Team T2, exec P6 Ian Carlisle goalkeeper 599. 0. The all task. As a convenience, the all task will build, package, deploy, and run the application. To do this, type the following command, and all the address book application. The address book example application is a simple web application that stores contact data. It uses a single entity class, contact, that uses the Java API for Java Beans validation to validate the data stored in the persistent attributes of the entity, as described in validating persistent fields and properties. Bean validation constraints in address book. The contact entity uses the not null, pattern, and past constraints on the persistent attributes. The not null constraint marks the attribute as a required field. The attribute must be set to a non-null value before the entity can be persisted or modified. Bean validation will throw validation error if the attribute is null when the entity is persisted or modified. The pattern constraint defines a regular expression that the value of the attribute must match before the entity can be persisted or modified. This constraint has two different uses in address book. The regular expression declared in the pattern annotation on the email field matches email addresses of the form name, domain name, top-level domain, allowing only valid characters for email addresses. For example, username. Example. Com will pass validation, as will first name, last name, mail. Example. Com. However, first name, last name. Example. Com, which contains an illegal comma character in the local name, will fail validation. The mobile phone and home phone fields are annotated with a pattern constraint that defines a regular expression to match phone numbers of the form XXXXXXXXXXX. The past constraint is applied to the birthday field, which must be a Java util. Date in the past. Here are the relevant parts of the contact entity class. Entity public class contact implements serializable private static final long serial version inuid equal 1L, id. Generated value strategy equal generation type. Auto private long id, not null protected string first name, not null protected string last name, pattern regexp equal az0-9, $, and plus. Equal, plus az0-9, $, and plus, equal, plus az0-9, az0-9 az0-9, plus az0-9, az0-9 az0-9, message equal invalid. Email protected string email, pattern regexp equal. D3, D4 $, message equal invalid. Phone number protected string mobile phone, pattern regexp equal. D3, D4 $, message equal invalid. Phone number protected string home phone. Temporal JAVX. Persistence. Temporal type. Date. Past protected date birthday. Specifying error messages for constraints in address book. Some of the constraints in the contact entity specify an optional message, pattern regexp equal. D3, D4 $, message equal invalid. Phone number protected string home phone. The optional message element in the pattern constraint overrides the default validation message. The message can be specified directly. Pattern regexp equal. D3, D4 $, message equal invalid phone number. Protected string home phone. The constraints in contact, however, are strings in the resource bundle to install. Examples. Persistence, address book. SRC, Java, validation messages. Properties. This allows the validation messages to be located in one single properties file and the messages to be easily localized. Overridden bean validation messages must be placed in a resource bundle properties file named validation messages. Properties in the default package, with localized resource bundles taking the form validation messages locale prefix. Properties. For example, validation messages S. Properties is the resource bundle used in Spanish-speaking locales. Validating contact input from a Java server faces application. The address book application uses a Java Server Faces web front end to allow users to enter contacts. While Java Server Faces has a form input validation mechanism using tags in facelets XHTML files, address book doesn't choose these validation tags. Bean validation constraints in Java Server Faces backing beans, in this case in the contact entity, automatically trigger validation when the forms are submitted. The following code snippet from the create XHTML facelets file shows some of the input form for creating new contact instances. H. Form. H. Panel grid columns equal 3. H. Output label value equal bundle. Create contact label first name for equal first name. H. Input text it equal first name value equal contact controller. Selected. First name title equal bundle. Create contact title first name. H. Message for equal first name error style equal color. Red info style equal color. Green. H. Output label value equal bundle. Create contact label last name for equal last name. H. Input text it equal last name value equal contact controller. Selected. Last name title equal bundle. Create contact title last name. H. Message for equal last name error style equal color. Red info style equal color. Green. H. Panel grid. H. Form. The. H. Input text. Tags first name and last name are bound to the attributes in the contact entity instance selected in the contact controller stateless session bean. Each. H. Input text. Tag has an associated H. Message. Tag that will display validation error messages. The form doesn't require any Java Server Faces validation tags, however. Building, packaging, deploying, and running the address book application. This section describes how to build, package, deploy, and run the address book application. You can do this using either NetBeans IDE or Ant. Building, packaging, deploying, and running the address book application in NetBeans IDE. From the File menu, choose Open Project. In the Open Project dialog, navigate to Tut Install. Examples. Persistence. Select the address book folder. Select the Open as Main Project and Open Required Projects checkboxes. Click Open Project. In the Projects tab, right-click the address book project and select Run. After the application has been deployed, a web browser window appears at the following URL: http localhost 8080 address book. Click Show All Contact Items, then create new contact. Type values in the form fields. Then click Save. If any of the values entered violate the constraints in contact, an error message will appear in red beside the form field with the incorrect values. Building, packaging, deploying, and running the address book application using Ant. In a terminal window, go to Tut Install. Examples. Persistence. Address book. Type the following command, and this will compile and assemble the address book application. Type the following command, and deploy. This will deploy the application to Glassfish server. Open the web browser window and type the following URL: http localhost 8080 address book. Tip: as a convenience, the all task will build, package, deploy, and run the application. To do this, type the following command, and click Show All Contact Items, then create new contact. Type values in the form fields. Then click Save. If any of the values entered violate the constraints in contact, an error message will appear in red beside the form field with the incorrect values.